Welcome to the deep dive. Today, we're kicking things off with an image you might see every day on the highway, a car roof cargo box. You know, the kind people use for extra luggage on a family vacation. But what if I told you that seemingly mundane box could hold a secret weapon, one that's proving surprisingly effective in modern warfare? Today, we're pulling back the curtain on the Bulba Autobox anti-drone system. This isn't just about military tech, it's really a fascinating story of ingenious engineering, rapid adaptation, and how one nation is innovating on the fly to meet critical threats. We've taken an in-depth analytical review of the system, its development, its technical capabilities, and its strategic significance, and we're here to, well, give you the key takeaways. You'll discover how this disguise system works, its journey from basically a concept to the front line, its smart features, and how it stacks up against some of the international competitors. It's a unique blend of stealth, autonomy, and battlefield effectiveness. Really offers a shortcut to understanding a crucial aspect of modern defense. So the rise of drones, it's fundamentally changed warfare, hasn't it? They're no longer just futuristic gadgets.
Not at all. They're everywhere.
Hmm.
Reconnaissance tools, kamikaze weapons, just this constant, pervasive threat on the battlefield.
And that intense pressure must have created an urgent need for effective countermeasures.
Absolutely. And out of that necessity, something truly remarkable was born. What really stands out here is how quickly Ukraine moved to address this.
Mm.
The Bulba Autobox emerged as a direct response to this relentless drone threat. It was developed by Service Budtrans, a company from Rivne,
Right.
that basically right at the beginning of the full-scale invasion completely pivoted its operations to focus on defense production. It's quite the story.
Wow.
Yeah, they rapidly assembled a powerhouse team. We're talking leading engineers in aviation, radio electronics, high-frequency systems specifically to tackle this challenge.
And their efforts paid off almost immediately, I understand. Early prototypes were tested pretty quickly.
They were. They put them straight into combat conditions, and their effectiveness was confirmed by Ukraine's Joint Forces defense. So it wasn't just a hopeful concept, it was proving itself right from the get-go.
That's impressive speed.
Exactly. And this rapid success caught the attention of the Brave One Defense Technology Cluster, which led to official recognition and, crucially, support. So by 2023-2024, these Bulba complexes were already reaching the front lines. They were being actively used by border service units and the armed forces against Russian reconnaissance and kamikaze drones.
And there was that example from Kramatorsk.
Yes, that's a really compelling one. The city purchased, I think, 15 Bulba 12 Autobox units specifically to protect communal workers. These were people building fortifications near the front lines.
So not just protecting soldiers, but essential civilian operations, too.
Precisely. It highlights that blend of military and, well, societal defense, keeping critical work going.
That really underscores its real-world value. And development didn't just stop there, did it? The system evolved.
Oh, absolutely. It's seen rapid evolution, different modifications. It started as a 12-channel system, but now you can get it in 14 and 16 channels, covering an even wider frequency spectrum.
Adapting to new threats, presumably.
Exactly. Plus, they've diversified the Bulba family. There's now the Bulba 2.0 Anti-Mavic, a lightweight, 2-channel handheld device specifically for suppressing DJI Mavic drones.
So a whole range of solutions.
Right. It just shows how quickly innovation can emerge when the need is so critical, directly impacting lives and operations on the ground.
Now let's peel back the layers on this clever piece of engineering. The Autobox form factor. That's key to its stealth, right? It really just looks like a standard car roof box on an SUV.
Exactly. You'd pass it on the road and think nothing of it, never guess what's truly inside. That's the genius of the disguise.
So what is inside that unassuming shell?
Okay, so inside you've got sophisticated electronic warfare EW blocks. These are the brains of the jamming system. They're equipped with specialized antennas, cloverleaf, and quadrifilar types. These aren't your typical sticks. They're designed for full 360-degree omnidirectional coverage.
360 degrees, so no blind spots at all.
Precisely. The aim is absolutely no dead zones where a drone could slip through. And the system itself is continuously monitoring radio signals across a really broad spectrum, from 90 megahertz way up to over 6,000 megahertz.
Wow, that's a huge range.
It is. It's constantly scanning for those distinct signals, control signals, video feeds, GPS GLONASS navigation, anything that indicates a drone is nearby.
That real-time monitoring sounds incredibly sophisticated. But what happens the moment a drone signal is picked up? Does it need an operator to react?
And here's where it gets really impactful. No operator needed for the immediate response. Upon detecting a drone, the system automatically generates powerful interference.
Automatically.
Yes, automatically. In the relevant frequency bands, this instantly severs the drone operator link, disrupts its control, and scrambles its satellite navigation.
Okay, so it neutralizes the threat fast.
Very fast. And once the threat is neutralized, maybe the drone loses control, crashes, or just flies off course, the system automatically goes back into standby mode to conserve energy.
That level of automation must be crucial in a fast-moving combat environment. Saves critical second.
Absolutely. Seconds count, and removing the human reaction time is a major advantage.
That automation is impressive. Now, you hear about drones trying to evade detection by changing frequencies. How flexible is Bulba's channel architecture in countering that?
Yeah, that's a critical point. Frequency hopping is a known tactic. So, the system boasts 12 independent radio suppression channels. Think of each one as a specialist,
Okay.
targeting a distinct slice of the radio spectrum, everything from common 2.4 and 5.8 gigahertz Wi-Fi bands used by many commercial drones.
Like the Mavics and others?
Exactly, all the way to critical L1 GPS signals, common control link frequencies like 868, 915 megahertz or 433 megahertz, even 1.2 gigahertz used for some FPV video.
So it covers the main bases?
It covers the main bases, and crucially, it's configurable. The manufacturer can customize these channels per customer. It can support up to 50 subchannels simultaneously across that huge 90-6500 megahertz range.
50 subchannels, so it's highly adaptable.
Very adaptable. This adaptive jamming capability is vital for dealing with drones that might try to shift frequencies to evade a simpler jammer. It's not just a blanket noise, it's more targeted. Right, it's not just blasting everything, it's smarter jamming. With all this capability, how far can that protective shield actually extend, and what kind of power does it need? So the effective jamming radius is generally cited as 200-300 meters. This creates an invisible dome of protection, if you like.
A dome. Okay.
Yeah, sufficient to protect, say, a platoon position or a specific guarded object. It's designed to neutralize threats like those common DJI Mavic or Autel drones before they get close enough to cause harm or gather intel. It's really about creating that local safe zone.
And the power output must need quite a bit of juice.
It does pack a punch. We're talking up to 1,500 watts total peak power output across all channels. Individual modules can reach around 50 watts each. That's significant energy focused on disrupting those drone signals.
Okay, 1,500 watts. That sounds like it would generate a fair bit of heat inside that box. How does it manage that? And what about just general endurance in the field? Can it run for long?
Good question. Heat management is definitely considered. It includes active ventilation for cooling. And the whole Autobox enclosure is built tough. It's IP65 rated, meaning it's dust-proof and protected against water jets. So it can operate in pretty harsh conditions, the spec sheet says, from -20 degrees C up to +50 degrees C.
So it's ruggedized. What about power sources?
It's got a dual system, which is quite flexible. It can run directly from the vehicle's electrical system, 12V or 24V, but it also has an internal battery for autonomous operation, maybe if the vehicle engine is off or it needs to operate briefly away from the vehicle.
And how long does that battery last?
Well, if it were jamming continuously at full power, maybe only 1 to 1.5 hours. But remember that automatic on-off function.
Right, it only jams when it detects something.
Exactly. So it only engages when a threat is detected. This dramatically extends its field endurance in standby mode. It could potentially sit ready for many hours, waiting for a threat.
Okay, so if we were to summarize its core strengths, you've got the full automation, the wide frequency range covering most common drone threats, its mobile and crucially hidden nature.
Don't forget the flexible power options.
Yeah.
The proven reliability in actual combat.
Right, combat proven. And significantly, it seems quite cost effective, around $8,000 USD, you mentioned?
Yeah, approximately 300,000 Ukrainian hryvnia, which is around that $8,000 mark. For this level of automated mobile protection, that's considered very competitive.
Yeah.
Those are definitely compelling advantages.
They certainly are. But like any system, it must have limitations or trade-offs, right?
Oh, absolutely. Every design involves choices. The 200-300 meter range, while good for close protection, means it won't stop threats detected much further out. It's for that immediate bubble. It also relies solely on passive radio monitoring. It doesn't have its own radar or optical sensors to find drones. So a completely silent drone flying on a pre-programmed GPS route, not emitting standard control or video signals that might potentially slip past it.
Okay. That makes sense.
And because it's putting out significant power across wide bands when it jams, there's a potential risk of interfering with friendly communications if it's not carefully managed and coordinated.
A deconfliction challenge.
Exactly. Plus, it's quite heavy, 80 kilograms, so it really is vehicle dependent. You're not carrying this around easily. And finally, it lacks sophisticated friend-foe recognition. It jams the targeted frequencies. It doesn't differentiate between friendly and enemy drones operating on those same frequencies.
So you could inadvertently jam your own assets if they're using similar signals.
Potentially, yes. These are all important factors that shape how and where it's best deployed tactically.
All valid points. Still, the cleverness of the engineering, masking powerful defense tech in something so ordinary, the way it uses specific frequencies and power for that protective bubble, and those deliberate design trade-offs for its specific role. It really is quite something. Let's turn our attention now to the brains of the operation. We've talked about its automatic response, but what does smart actually mean when we talk about Bulba's threat detection? Is it genuine AI?
That's a good question. The term AI gets used a lot. In Bulba's case, it's primarily about intelligent pattern recognition. The system continuously scans for specific spectral fingerprints.
Spectral fingerprints.
Yeah, the characteristic radio signatures of UAV signals, things like standard Wi-Fi protocols, specific digital radio channels like DJI's Lightbridge or OcuSync, common analog FTV video transmitter frequencies. It knows what drone signals look like electronically.
Okay, so it has a library of known threat signals.
Essentially, yes. While the developers haven't detailed, a full deep learning neural network running inside, Bulba absolutely uses intelligent algorithms for its automated response. It's less about complex reasoning and more about speed and reliability.
Right. So the smart part is the automation based on recognizing those fingerprints.
Exactly. It's about acting faster than any human operator possibly could, conserving battery life by only activating when needed, and minimizing human error in high-stress situations. These algorithms perform that crucial smart task of timely detection and suppression.
So it's a powerful example that AI in defense isn't always about, Skynet-level thinking. Sometimes it's about critical, high-speed automation.
Precisely. That distinction is important. It highlights how much you can achieve with smart, targeted algorithms, even without full machine learning in this specific instance.
When we look at future potential then, and maybe compare it to other systems out there, where do you see Bulba evolving, especially regarding more advanced AI?
Well, the key seems to be the modularity of its software architecture. That's often crucial for defense tech. While Bulba currently might use a, let's say, lighter approach, perhaps focusing on filters and known signatures,
Okay.
it's likely designed for future updates. You look at systems like Israel's Skylock, for example,
Yeah.
that often cited as a leader. They do integrate more advanced AI for deep classification.
So deep.
They claim recognition of over 500 different drone models using machine learning. They can incorporate friend-foe recognition, even attempt operator geolocation based on signal analysis. It's a different level of AI integration.
So could Bulba head in that direction?
Potentially, the roadmap could certainly involve integrating more advanced AI for, say, better drone classification. Maybe telling the difference between a small commercial quadcopter and something larger or military grade. Or it could integrate with external sensors, maybe optical or acoustic, to help differentiate friendly drones from hostile ones. That would address the friend-foe issue.
And are other Ukrainian systems exploring this?
Yes, definitely. You see systems like FCK, which apparently uses mobile station analysis and crypto protection features, and another one called Pascha is specifically positioned as an autonomous AI platform. So Bulba fits into this spectrum of evolving Ukrainian EW capabilities, starting strong on automation with clear potential for more sophisticated smart enhancements down the line.
Okay, so it's clear that AI in this defense context covers a whole range, from that vital, fast automation Bulba excels at, right up to advanced machine learning for classification and prediction. It's fascinating to think what future versions of Bulba might be capable of. All right, let's zoom out now and place the Bulba Autobox on the global stage. For any defense technology, especially one hoping for wider adoption or export, things like standardization become really important. You mentioned NATO codification. Why is that such a big deal for a system like Bulba?
Oh, it's absolutely critical if you want to play on the international field, especially with NATO countries or partners.
Yeah.
Getting a NATO stock number and NSN. It signifies a lot. It means the product meets specific, agreed-upon technical requirements. It confirms it can be officially procured through NATO channels. And crucially, it can be integrated into the complex logistics chains of alliance members. It basically opens the door to potentially huge markets and signifies a certain level of quality and interoperability.
So it's like a seal of approval, but with practical implications for buying and using it. Where is Bulba in that process?
It's well on its way. The reports say it has completed state trials successfully and has received cataloging by the Brave One defense cluster in Ukraine. This is often a key step towards formal NATO codification. It's following a path that apparently over 30 other Ukrainian EW systems are also on. So it's part of a broader push to get this battle-proven tech recognized and available internationally.
That's a significant step for market entry. But okay, once it's potentially playing in that bigger league, how does this agile, relatively low-cost hidden system stack up against some of the established global giants? Let's talk about Skylock from Israel again. You mentioned them as a leader.
Right. Skylock is often seen as, maybe, the Rolls-Royce of counter-drone systems. Their portable setups can detect and neutralize drones much further out, sometimes up to 2.5 kilometers. They use multi-sensor arrays, not just RF detection like Bulba, but also acoustic sensors, optical cameras, even mini radars.
A whole suite of sensors.
Exactly. And as we discussed, their deep AI capabilities for classifying hundreds of drone models are very advanced. But all that capability comes at a significantly higher cost and complexity. Skylock often serves more of an operational or even strategic role, protecting large bases, critical infrastructure, maybe even small cities.
So a different weight class, essentially.
Pretty much.
Yeah.
Bulba, in contrast, is positioned as a more tactical, highly cost-effective solution specifically for close-range defense. Its niche is being simpler, more accessible, rapidly deployable right where needed, maybe with frontline units or mobile patrols. They're solving slightly different problems, or at least addressing them at different scales.
Okay, that makes sense. What about DroneShield from Australia? They're quite well known, especially for things like their handheld drone gun. How does Bulba compare there?
DroneShield has a range of products, too. Their handheld drone gun is effective, but requires manual aiming by an operator, and it typically covers fewer frequency bands than Bulba's automatic system.
So operator dependent.
Yes. They also have vehicle-mounted options, like the Drone Sentry X. That's perhaps a closer comparison, but often it still has more limited channel coverage than Bulba's 12, 14, or 16 channels, and it's frequently paired with radar for initial detection, adding complexity and cost. Bulba's unique selling point seems to be that blend of automatic, 360-degree coverage across a wide spectrum without needing external radar, all while being mobile and disguised. That autonomous protective bubble on the move is a key differentiator.
And comparing it within Ukraine itself, there are other Ukrainian EW systems like REX-32.
Right, Ukraine has developed several portable EW systems. Things like the REX-32 or the Bukovel AD complex are often very effective, but they tend to be either directional, you have to point them, or tripod-mounted for stationary defense.
So less mobile or less comprehensive coverage?
Generally, yes.
Yeah.
Bulba's disguised, on-the-move 360-degree approach offers a different kind of utility. That ability to provide an effective protective bubble for a convoy in motion, for example, is hugely valuable for dynamic frontline operations. It seems to strike an optimal balance between universality, covering many drone types automatically, and compactness or mobility compared to larger static systems or more limited handhelds.
So Bulba really carves out its own distinct market niche then. It's this effective, close-range anti-drone system, perfect for frontline units, maybe protecting small critical points or convoys. It's cheaper and simpler than those big multi-sensor complexes, but offers broader automatic coverage compared to most individual handheld units. And that Ukrainian origin, being developed and tested right there on the front lines, must give it a huge advantage in terms of rapid adaptation to evolving threats.
Absolutely. That feedback loop from the battlefield back to the engineers is incredibly valuable and something Ukrainian companies have leveraged effectively. This also points to immense market potential, both domestically and internationally.
Domestically first, is there potential for mass production?
It seems so. There's obviously a huge need within the Ukrainian armed forces. State contracts would be key. And interestingly, the manufacturer, Service Budtrans, apparently launched its own PCB-printed circuit board printing line back in May 2025.
To make their own circuit boards.
Exactly. The stated goal was specifically to reduce production costs and dependencies, suggesting they're gearing up for larger-scale manufacturing.
And that naturally leads to thinking about export opportunities.
For sure. The global demand for CUAS counter-unmanned aerial systems is exploding. Bulba has that crucial battle-tested label, combined with cost-effectiveness. That could make it highly attractive to NATO partners looking for affordable tactical solutions, or perhaps medium-budget armies, maybe territorial defense forces globally.
You could even see it being used by, say, UN peacekeepers or police convoys needing protection against drone threats in unstable regions.
Absolutely. Its non-military appearance could even be an advantage in some of those scenarios. And achieving that NATO codification we talked about will only make the export process smoother, opening more doors.
The investment side looks interesting too, then.
You'd think so. It's a rapidly growing market sector. Bulba has unique features: the mass design, the autonomy, the wide frequency coverage. Its modular architecture allows for flexible configurations and future upgrades. And the fact that the company produces other defense products suggests potential synergies. It paints a picture of an innovative company addressing a critical modern need.
It really is an exciting story of innovation, isn't it? Born from direct necessity, but resulting in something with potentially global relevance. So, just to wrap up our deep dive here, the Bulba Autobox really stands out, doesn't it? It's an innovative, highly practical, and perhaps most importantly, battle-tested Ukrainian solution for anti-drone defense.
It really does. It brilliantly blends that crucial stealth factor hiding in plain sight with full automation and remarkable adaptability to cover a wide range of drone threats.
Its immediate value is clear on the front line, protecting troops, protecting those essential civilian workers we talked about. It's proving its worth daily in incredibly challenging circumstances, a real testament to that agile, needs-driven engineering.
Absolutely. And looking ahead, its potential as an export success story seems quite significant. It also highlights this ongoing rapid technological arms race, the constant back and forth between drone developers creating new threats and counter-drone systems like Bulba trying to neutralize them. It's a very dynamic space.
It is. And maybe that leaves us, and you listening, with a final thought. How this kind of agile engineering, this rapid iteration, often born from sheer urgent necessity, is genuinely redefining modern warfare.
Right. It's creating these unforeseen technological solutions, like Bulba, that cleverly blur the lines between what looks like a civilian object and a capable military tool. What does this dynamic really mean for the future of conflict? And how will the nature of defense technology continue to transform when rapid, battlefield-driven ingenuity becomes such a potent weapon?
That's definitely something to ponder. Thanks for joining us on the deep dive. We'll see you next time.